Now we're recording. Cool. Okay. Where did you find the share screen option?
Just down at the bottom.
Oh.
Right.
Yeah, it was like, it's green on mine.
Okay, do you guys see the Google Earth thing I'm on?
Yeah.
Sick. Cool. So you can, in your share options, you can share either your screen or you can share like one thing. At least when you have Zoom downloaded on your computer. I don't know about you guys. Okay. So here is Google Earth. We can all just look at mine if you guys want, because I have it like the full thing downloaded on my laptop. Okay. Julio. Okay. So the first thing we need to do is find Mount Rainier.
Yeah, that's in Washington, so just type it in the search box.
Just kidding. How do you spell Mount?
RAI.
There we go. Here we go. Oh, that thing's huge. Holy crap. Do you guys see like the elevation?
Yeah.
That's ginormous. Cool.
Yeah, I have a thing. Okay, so I actually, when I was looking at it earlier, I actually wrote down so the peak was like around 14,300 feet high, like 329. And then, yeah, and so I tried to look for like the furthest east part and the west part, and I got like 699, like, or yeah, 6,993 for the east, like lowest elevation. But like the question is, how do you like decide where the mountain ends and where it begins?
I'd say like the elevation. You see like here around this region. Can you see my mouse?
Yeah.
Oh, sick. Okay. So I'd say like if you just look at the topography, you can kind of see when the elevation kind of like levels more out, maybe.
Mm-hmm.
Like maybe because it's this little thing. That's a little hill. Okay. But I'd see like around here. So around here, maybe. I don't know. I love looking at this kind of topography. It's so cool. Okay, lines. I mean, I can show my ruler. Oh, here we go. That's line. Okay. So a line from north, which is totally at the top right now. Whoops. That didn't work. Why isn't that working? There we go.
Oh.
And then we go east. Oh, that didn't work. I want another one. Can I do another one? Okay, save. Don't want that. Okay, that didn't work. Okay, anyways, so we have to have the intersect. Let me try that one more time. Probably like over the top we want it. We'll save that as and then we'll go east to west.
I'm gonna get my charger. My computer will die soon.
Oh, that's so high. Yeah, I want that.
Drainage.
Say that again?
It says make sure you draw your lines following the drainage or the lowest elevation as you come off the main of the peak.
Right. Okay. So we want that line over there then. Lines. Because this is the peak. There we go. Because that's the main peak there.
Good.
Yeah. Oh no, it's not. What the? Ugh. This is frustrating. Just gonna go close, like here to there.
Yeah.
Better. Better. Okay, this thing is annoying. It's just in my way. Yeah, I'm in a group meeting now. I'm burning a Bath and Body Works candle in my room. My mom came and she's like, "Is that what the candle I think it is?" Yes, Mom. Okay. Do you think that's good? That's like peak? Yeah.
We think, no, because like, if you look at the pinpoint there, the pin, if you, yeah, if you actually manage to do that, then that should be the actual
This?
peak. Highest point right there, right at the pin, right there. Yeah.
Okay. So I guess I was pretty spot on with this one.
Yeah.
Okay, I'd say that line's fine then. Okay, so later I will figure out how to delete these lines. But, oh, there we go. Okay, so let's do this one real quick. Sorry this is taking long.
Oh, it's no worries.
See about there? Yeah? That looks like a drainage kind of thing.
Yeah. That looks fine.
Yeah, that's good. Okay.
And where you start seeing like green parts, that's like a good thing right there, yeah.
Yeah. Cool. Okay, so we did that. Okay, look at the elevation of the east to west and what kind of volcano do you think it will be? I'm guessing stratovolcano / composite.
It definitely looks like a strato. I like with the way that it's like.
Yeah, I think it looks like a stratovolcano.
I wouldn't be surprised if it actually also ends up going like parasitic cones along the side somewhere at least.
Yeah. I'm just sorry. I'm just looking at the questions. I'm not you. I'm still listening.
Doesn't Mount Rainier have like a lake though, kind of like on top of it?
Oh. How irritating. Sorry. Look at the elevation.
I'm looking up if there's a lake.
How can I? Yes! Oh, that was so easy. What the heck? Okay, sorry. I just figured out how to delete the line. Okay, so we're looking at the elevation. Do a screen capture of the elevation profile.
Of the east to west transection.
There we go. Does that, like about there? I'm just gonna make this big. Does that look like what he wants, you think?
Yeah, it does. I mean, based on the instructions that I gave, that's pretty much what it looks like.
Okay, so I just did screen capture, and I'm going to copy.
I didn't realize Paradise was right next to Mount Rainier.
Really?
That huge wildfire.
Yeah, it's like right there at the base. Like right there.
The west side of the mountain has the lowest elevation.
Why isn't that working?
Paradise has had a lot of natural disasters hit it.
Let's try that again.
elevation profile of the ECS concept. We use that to create an illustration that resembles the kind of.
Oh, I'm stupid. Sorry. Just ignore me. I'm just
So for like
copying.
the second point of the assignment, it says to do a screen capture, and then we have to illustrate the architecture. Or are they actually talking about like how we actually kind of like actually cut the mountain in half and then
So
scale cost kind of thing?
do a screen capture of the elevation profile. Okay, so I have the picture. I just screen captured it. Oh, and use that to create an illustration that resembles the kind of architecture you would expect for this kind of volcano, which is so easy because literally watched videos of it.
Yeah.
Be sure to annotate and label your illustration. You're just asking for more work. Sorry, Professor. You're watching this part right now. Okay, that's super easy. I don't. Do one of you guys want to like particularly do that? You basically we're just drawing a picture of a stratovolcano because we all agreed we think it's a stratovolcano. We're all just drawing a picture of it and then just like lines like, oh, this is this part of it probably, and this is this part of it.
Do we create the illustration on our computer?
So if one of you did that, and then you could just take a picture of it and send it to me, and I could just insert it into this.
Do you want an actual drawing, or do you want us to draw over the volcano? Like, draw over the screenshot that you.
I think draw a different illustration.
Yeah.
Okay.
I wonder if I
So, what would he want us to label?
that is a very good question. I think it just the basic autonomy of a stratovolcano.
Okay.
Like, this is the peak of it.
So we would actually have to draw layers of it, and then we also have to do like. Oh, that's a pretty good. Yeah, that's a pretty good line.
I'll start drawing.
Okay, you're gonna do it, Emily?
Yeah.
Okay, thanks so much. And you could show like certain drainage points too. I'll take a picture of this really quick because we're gonna be doing some other stuff and just text it to you guys so that you have that.
Mm-hmm. Elevation profile for both concepts created by which side. Oh, we also have to label the elevation.
Ooh, yes. So we need to.
Lowest and the highest. So we could possibly like on the right side of, so like on the east side, like just right when you see the end of that picture, we could possibly do that one. And then on the left one, you could just.
Okay, so our elevation. Ooh, okay. So if you guys look down here at the bottom, it shows the elevation.
Yeah.
So when I'm in the intersection of it, it's about like 4,340. We could say 4,300 meters tall.
Yeah.
I'm gonna fact check that and Google it.
Wait, is this supposed to go on the picture that I'm drawing?
Yeah, you have to label that as well.
Oh, guys, we're so good. It's 4,392.
4,319.
Yeah.
4,392 feet.
Meters at the peak. Meters at the summit, actually. Yeah.
For those. I wish I could share. Maybe, okay, I'm gonna go stop share and then I'm just gonna try and share my whole screen with you guys so that I can. Yeah. Yeah, I'm just gonna share my screen with you. So you see the assignment now? That I'm
Yeah, I see it.
So we did that part. Sorry, this first bullet. On the second bullet, we did a screen capture. I just put the elevation in there too. And then we'll put in your illustration right there when you send
Make sure
it.
you say meters, because when I saw it on your screen, it actually showed meters instead of feet.
Yeah, it is meters. Most elevations worldwide, besides the US,
They use
meters.
So I have the elevation and the summit labeled, and then I have the crater on it labeled at the top. And then it's kind of confusing to me because he doesn't tell us exactly what to label.
well.
So you're leaving what's typical. Sorry, go ahead, Alicia.
No, it's okay. It's alright. From just a bit, like they only want it, like he only said to label like the highest and the lowest elevation, north and east, south, west.
Or that's the I think so. Whoops. No, sorry, that's a different class. Where is it? There you go. So compare the elevation profiles for both transects created above.
Like I think we actually have to identify which side is the lowest. So we actually have to figure out.
That's the next bullet. So bullet number 2.
Yeah.
The kind of architecture you would expect for this kind of volcano. So the kind of architecture you'd expect of a stratovolcano.
So there'd be layers, and then occasionally there'd be like some parasitic plants somewhere.
Like vents and stuff, maybe.
Okay.
Does that make more sense?
Yeah.
Yeah.
Sweet. Okay. So that will be for that second. Okay, the third bullet point, compare the elevation profiles for both transects created above. Which side of the mountain has the lowest elevation? So the east side or the west side? So
Based on your line there at the end of that little volcano on the east, like just outside of that, the lowest that I found is like 2,741 feet. And in meters,
so it seems, so just looking at this bottom part that has elevation, I'd say like looking at the bottom of the west side of the volcano, it's about like 1,200, we could say. And looking at the bottom of the right side, the east side, it's about 1,400. Yeah?
1,400. We're talking meters, right?
Yeah, sorry, meters.
Yeah. So just outside of that east side one, instead of like 14 or something like that, just at the base of that tiny not volcano, but like tiny mountain off to the side of Mount Rainier. Like east side. Yeah. Like a little bit further out from your line that you drew.
Like right about there?
Hold on, let me pull that thing up.
Oh, right here? The divide?
I don't know if it's green. Okay. No, east, go east. So like just put your cursor out to like the end of that line that we drew, west to east.
Mm-hmm.
So just past that bump on the outside. Just down in that divot.
Oh, right here?
No, on the east side, so that's west.
Oh my gosh, you're right. I'm so sorry. Right here?
Just outside, right down in the middle, right there. Yeah, up there, up there. So if we're gonna go for that one,
Holy.
yeah.
Yeah.
So it's around 849 meters.
Uh-huh.
And so the point that I found was 833 meters, 834, give or take.
Okay.
So if we want to use that one as like the end of the thing, but then like this is a whole mountain range. So
Right. So we're looking at, okay, just which side of the mountain has the lowest elevation. So if we're like using that,
yeah, at the end of it.
we could round it up to like maybe 1,000 meters. And then if we're looking like kind of at the end of this, it's still more than 1,000.
Okay. What do you think, Emily?
I think the numbers don't lie.
Okay. So we'd say east side. I always
Yeah.
get east and west mixed up. I don't know why. Because I know all the little nursery rhymes to remember.
Never eat shredded wheat. Yeah.
Oh. I never eat soggy wieners was the most popular one at school.
Oh, okay.
Or never eat soggy waffles. But
Yeah, I learned never eat soggy waffles.
okay. What was it? The east side. East side of volcano. Cool. What consequences could possibly result on the side with the lowest elevation as a result of the topography? Take into consideration the type of volcano this is and what potential hazards exist. Oh, so much. One of them being, I don't actually remember it. Yeah, the text talked about them, I'm pretty sure. Lahars. Did the text talk about them?
Well, for one, like based on the drainage pattern of the mountain itself, there's definitely going to be stuff flowing into that area. Like
Exactly.
just south of that, just that whole area south of that line that you drew on the east side is going to be covered in lava.
Bring down any lava, pyroclastic flow.
Yeah.
Plastic flow. Pyroclastic flow, or
It's probably going to be more if one side is more like lower elevation than the other one. Because like if another side has a higher elevation, it might be because it has erupted before and it's like built up layers. So it could mean that the one side is like thinner and it could erupt from that lower side.
So then, like, okay, it could. So basically, there could also be like the possibility of like a fissure or a vent developing there as well, and then a parasitic cone will develop there on top of it.
on the other hand, the side the elevation.
I would feel like, okay, based on like pictures that I've seen of the mountain, I feel like the pyroclastic flow will be kind of like the crumbly kind, not like the gel viscous kind of stuff that you see in Hawaii.
It's not viscous, no. Pyroclastic flow is more like debris and chunks and everything.
Okay.
It's more explosive.
More explosive, yeah. Wait, so we'll say on the other hand, the side with the higher elevation could be higher due to some, oh, what's that called? The tilt. The tilt. Sorry. Not making sense. Oh. Oh, so due to the tilt of the Earth, and so when a volcano is erupting, the Earth will usually tilt a bit.
Really?
Yeah, it does. It's so crazy. So they have this technology used to like measure the tilt of the Earth. Isn't that crazy? I had no idea about that until I just took natural disasters, a foundation science course, and so I learned a bit more about like some of the technology they use. And I'm like, oh yeah, and tilt. I was like,
Okay, so do you think that the tilt would actually have to do with the fact of the force of the eruption, or is it like more of the release of the pressure? So then like there's a bit of like, you know, when there's pressure buildup, it kind of like expands a little bit, and when there's a release of pressure, like just kind of like tips back down a little bit, or like.
I do think it has a lot to do with like the magma and everything just moving
Yeah.
around.
Okay.
Because that's totally what happened to I always forget how to say it properly, Kilauea, in Hawaii,
Uh-huh.
when it was erupting last May, or the
Oh,
May before that. Did it erupt in 2017 or 2018? It just happened, didn't it? We were in
that's
class together, Emily,
weird
when that happened.
mythology.
But that's what happened is there was one of the main areas, chambers, collapsed because the magma was draining into a different chamber, and that's where it ended up erupting from.
Oh, okay.
Cool stuff. Okay, why are we saying, on the other hand, the side with the higher elevation could be higher due to...
Previous eruptions that had like layers of slow flowing or pyroclastic materials that just built up on top of it.
So apparently, I've been looking at Mount St. Helens. Apparently, before the blast happened, like on the side of it was a landslide, and so when the landslide happened, it like shifted down, and then the blast like shot out behind the landslide. So like if it's lower elevation on the one side, like that means that there's a steeper fall, which means there's more possibility for a landslide to happen, which could like allow the volcano to erupt from those vents.
Oh, so it's just kind of like when you have like a buildup of like a scab on your pus kind of thing, and you kind of like remove that scab, so then like, okay,
Mm-hmm. Yeah.
kind of like that thing basically. Okay.
There's gradations for a
Yeah. Why?
occur during we don't get good points for that answer. I don't know what is going on. Okay. Next bullet. You predicted the kind of volcano this would be. Based on that answer, what rock types might you find in this area? Oh. Basaltic. Right? Basaltic?
Yeah.
Yeah.
Basaltic. Yes.
Or basalt.
Yeah. Basaltic. Magma is
Well,
I don't know. I don't remember exactly if pumice is the right thing, but
yeah,
it's
so
pumice.
pumice, scoria, just depending on those all depend on how much gas is
Built up in the
built up in the
chamber.
volcano too. And these because there's an eruption, there usually is a lot of volatiles.
Yeah. Well, there's definitely gonna be like more gas and stuff in here.
Apparently our meeting is ending in 10 minutes. Thank you, Zoom. Gosh.
I don't like time limit.
No.
But basalt is mafic, so maybe a more encompassing
Oh,
term is mafic
granite.
rock.
Is it granite then?
Yeah. Wait, let me Google it.
We just studied this. Um,
I don't know. This stuff always confuses me.
oh, I have it written down.
Okay. So there
I took notes. Here it is. Okay, 1 second.
hyperception andesite.
I wrote this down.
Um, small amounts of hornblende.
Oh, andesite. Andesite. Because
Andesite.
intermediate rocks are the most common.
Andesite. Salt and
Andesite. So intermediate. Ash, cinders, gases, volcanic bombs. Those are all, those are all really common because it's layers of like the lava and the pyroclastics. Oh, so diorite and andesite are both intermediates. Oh, felsic, that was the other one. Mafic is basalt and gabbro. Granite and rhyolite are felsic. So, stratovolcanoes. Layers of intermediate composition lavas. Do you think that granite would be there though? Like some of the
there's a
felsic?
possibility, but I don't like. I think it's more like higher than that.
Okay, so more like andesite, diorite.
Yeah.
And then
Yeah. I think it's gonna be darker colored rocks.
yeah, for sure.
Do you think there'd be hornblende as well?
Intermediate have like there's 60% silica usually. And the mafic ones have like very little silica, around 50 or less than 50% silica, so they're lighter colored. Like Yellowstone is all rhyolite, which is like totally white. And then the felsic, right? Yeah. Yeah, Yellowstone is felsic, rhyolite, 70%, mafic, 50%, which is basalt, and gabbro. Should we list pumice or scoria as possibilities?
Yeah, because those are like one of the most common kinds of rocks that would actually come out.
Yeah. Okay. Okay. We're almost done. Okay, take a close look at the mountain and its surroundings. What other geological features do you find there? There's this is Mount Rainier, sorry. What other geological do you know the area? It's close to the ocean.
It's right. Okay, so like it's probably just right under where
there are other
oceanic
volcanoes
melting under. Like it's just over like the spot where like the other plate could be melting under. So yeah.
I would say there's a river.
We could say like rough / uneven terrain.
Yeah, that's good.
back out a ways from Mount Rainier and answer the following. Is it near plate boundaries? Okay. So I have
It's right near the Wanderkuchen plate as well as the oceanic plate.
Juan de Fuca
Wanderkuchen.
Convergent plate boundary. Okay.
It's just right on the outside of the left side of the whole mountain range, actually. So
Uh-huh.
yeah, so that's probably like where like most of the plate, like the subduction plate would melt, and then like everything would just build up and like push up there. Apart from the fact that you know how the continents have to kind of like fold a little bit when they're actually like in contact with the plate.
So it's about 326 kilometers away from the plate boundary.
Okay. West of the mountain.
The oceanic plate is subducting underneath the continental plate. So Juan de Fuca plate. I'm just trying to get this down and then I can like make it look better. So you just like they write like for years. Subducting
North American plate.
Yes. Plate. Do you think that there's any relation between the tectonic setting and the occurrence of Mount Rainier?
Absolutely.
Yes. What's it called? An island arc system?
In Archipelago?
Archipelago. Oh my gosh, I can't spell. I know what you're talking about.
But you get what I mean, right? Because it's subducting their volcanoes forming on the continental.
Mm-hmm.
Like, it's like.
Yeah, it's formed by subduction.
Yeah. Okay, I can type that in. Okay, are there any other noticeable volcanoes in this area within a few hundred miles? Yes.
Yes.
There are. What do you notice about them? Ooh, they form like a line. Oh my goodness, look at
Yeah,
this.
they're in a line along the. They're like
Yeah,
the same
that's the
distance
whole mountain range, basically.
Yes.
from the plate boundary.
Yes, they're in an arc. Not an island arc, volcano arc. That's what it's called. Gosh.
Yeah.
These aren't islands. Okay, volcano arc.
Are there any other noticeable volcanoes in this area? Yeah, Mount St. Helens.
Mm-hmm.
That's right, Mount St. Helens, one of the notable ones.
I can list a few more, and then less than a minute.
It's okay, we don't have to rush.
But basically, yeah. Okay. So Emily, do you want to just send me that picture?
Yeah. Well, okay. So, y'all think that I should label on it that they're typically like rock types in the volcano, like within the like actual cone?
You could, yeah.